From analog.
Hi, Jim. You've a great signal up here. You're 5.9 plus.
You're digital.
We are everywhere you want to be. This is the CQ Blind Hams Podcast.
This is Butch butchWA0VJR, and some of you have asked me to do kind of a little demo of what we can do with our new talking meters. This particular one is the $20 one I got off of Amazon. Anyway, before we get into the actual meter itself, I thought I would explain some of the units that it measures. It measures voltage, which is the amount of force or the amount of pressure available to push current through the circuit. You have voltage, for example, on your plug-ins in your house, 120 volts, but there's no circuit, so it just sits there. However, if you touch it and complete the circuit, it will bite you. Current is the amount of electrons going through the circuit. In other words, how much is available. And what controls that amount is called resistance. That's exactly what it says, the resistance of the circuit to limit current flow. Apologize, my voice isn't good. My allergies are really killing me. Anyway, so to kind of put some of that in perspective, we're going to go into what is called Ohm's law. And the Ohm's law formula is E, which is voltage, equals I, which is current, times resistance. Current in amps, resistance in ohms. Now you can switch that formula around to resistance equals voltage divided by current, or you can have current equals voltage divided by resistance. And I'll demonstrate that when we actually measure voltage and current, so you'll kind of understand how that works. If you know any two of the three, you can solve for the other one. Another formula, which we won't use probably much, but I'll at least tell you what it is in case you want to know. If you want to solve for some of these and you know the wattage, you can use the formula watts equals E squared over R, which is voltage squared divided by resistance. Or you can use wattage equals I squared times R, which is current squared times resistance. A couple other things to mention is we'll get into AC and DC measurements. AC is alternating current. And if you picture a line, a horizontal line, which is we'll call the zero timeline, on AC you have the voltage goes above that line, drops back to the line, and then goes below that line, which is reversing polarity, and then back to the line. That is one complete cycle. In the United States, we have 60 of those every second. In DC, the voltage goes above the line, stays above the line, and when you turn the power off, it goes back to the line. So it's one polarity, plus or minus, but it never changes. That's why it's called direct current. I noticed some of you mentioned putting the meter in current mode and putting it directly across the battery. You're lucky you didn't fry your meter. In current mode, the meter must go in series with the circuit. In other words, a series circuit would be power supply positive to meter positive, meter negative to load positive, load negative to power supply negative. So everything has to go through each part of the circuit in order. If you break one part of that, the whole circuit shuts down. That's why Christmas tree light bulbs, they're in series generally. If one bulb goes out, they all die because they're hooked from one to the other to the other. They're not in parallel. A parallel circuit would be resistor goes from plus to minus across your power supply. The meter also goes positive to plus, negative to minus. So that's a parallel circuit. That's how you measure voltage. Let's go to the description of the meter itself. if you put the meter with the display to the top, below the display you have 3 buttons. Those buttons are left button as the function button, where you switch from volts, ohms, current, and so forth. You'll see that as we go through this. The middle button switches to a mode which is kind of a field strength. It senses if there's voltage present in the line. You don't actually make contact, but you get the meter near the AC line and it will beep. The right hand button turns on a flashlight, which we don't need. The button below that, the big round button, turns the meter off and on. Across the bottom of the meter you have 3 jacks. The left hand jack is a positive for current to amps. The middle jack is negative. The right hand jack is positive for voltage, diodes, and so forth. If you don't have the batteries in yours, I'll very quickly tell you how. If you turn the meter over, and you'll see a little pop-up thing that's made so you can stand the meter at an angle. At the very bottom of the meter, about the middle, about 3/4 of an inch from the bottom in the center, you'll see a little tiny hole. There's a little tiny Phillips screw in that hole, and you have to take that screw out to get the battery door off. Once that's off, the batteries go in as you would expect, the spring to the ground, and the other end of the positive takes 2 AAA batteries. Once you put that back on, you're ready to go. And when you put them in, you'll hear it say something like,
already on.
It'll turn itself on. Oh, let's start measuring some things. First thing I'm going to check is a 1.5 volt.
Over range.
And it says over range battery because I'm not connected. So we'll touch it to the battery, the 2 probes.
DC voltage measurement 1.581 volts.
And that's with the plus on the plus, the minus on the minus. We'll reverse polarity.
DC voltage measurement minus 1.582
And that's minus, which means we have it reversed. If for some reason your meter stops saying minus, as mine has done a time or two, to turn that back on, you
over range.
Turn the meter off. Yes. I wish it would quit talking. There it did, maybe. Anyway, the meter off, hold in on the left-hand button while you power the meter on. Keep that button held in for about 2 seconds, and that will restore the minus. Now, I want to check the voltage of my power supply here on the workbench. It's a big Astron supply. So we'll see what it says it is.
DC voltage measurement minus 13.70 volts.
And I have the probes backwards, so we'll reverse them with the plus to the right.
DC voltage measurement 13.69 volts. DC voltage measurement 13.69 volts.
So 13.7 volts, pretty close. The other thing that this mode is good for, if you want to check the various wall warts or little transformers you have around the house, and you can tell whether they're, which part of the plug is minus, which is plus. Generally, the outside of the plug, the little coax plug, is minus. The center is positive. However, with the double talk, it's just the opposite. Don't know why, but the double talk, the outside or the barrel of the plug is positive and the center pin is minus. Next thing that comes up is AC voltage measurement. The nice thing about this meter, it is auto ranging. You don't have to select a range. so I can just measure the 110 volts. I have on my workbench here an isolation transformer, and it has plug-ins on the top, and I can switch voltage to those plug-ins. So let's try the first one here, plug-in.
AC voltage measurement 104.9 volts.
So that's 105 volts. Now if I crank it wide open,
AC voltage measurement 129.7 volts.
so it goes 104 to 130 volts ballpark. So you can change the voltage if you want to, depending on what you're working on. The isolation transformer isolates what you're working on from the main circuit. So if you have an AC-DC radio, in some cases, if you have the plug-in wrong, the chassis is hot. The whole chassis is 110 volts hot. If you run it through an isolation transformer, that's no longer the problem. Now we want resistance, which is in ohms. So if we short the leads, it beeps, and it's 0 ohms. Now I have a resistor here, and let's see what it says it is.
Resistance measurement 1.147,000 ohm. Resistance measurement 1.145,000 ohm.
So it's 1.1K or 1100 ohms.
Over range. DC current measurement 11.8 milliampere.
There we go, 11 mils.
DC current measurement 11.8 milliampere.
So it's 11 mils current. So now let's check that with Ohm's law and see how close we come. On the way, I hooked that up. The positive of the output of the supply went to the positive of the meter. The negative of the meter went to the resistor. The other end of the resistor went to the negative terminal of the power supply. In other words, a series circuit. So the current flows through both of them. I moved the positive jack, which is we generally use for voltage and so forth, on the right to the left-hand jack, which is used to measure current. So now let's plug that into Ohm's law, which is current equals voltage divided by resistance. So let's do 13.5 divided by 1100 ohms, ballpark,
1100
equals
0.01227,
and we come out with 12 mils, which is exactly what we measured, and that's how Ohm's law works. And while we're on the subject of current, AC current you would measure the same way. However, this meter isn't made to handle very high current, such as what your air conditioners would take. You need what's called an amp probe, which clips over the line, and I don't know of any one of those that talk. Another trick you can use to measure current, if your meter won't measure high enough, is to put a resistor in series and measure across the resistor. For example, let's assume your television takes 2 amps. At 120 volts, that comes out to be 60 ohms of resistance. So if we took a 6 ohm resistor and put in series with that, you would measure 12 volts across that 6 ohm resistor. Therefore, you could calculate that the current is 2 amps in the series circuit, which is exactly what it is. So there's kind of a way around it. If your meter doesn't go high enough, you can put a resistance in series. You may recall when I was describing AC and DC that AC goes both directions, DC only one. A diode only allows current one direction. So if you put a diode in series with an AC voltage, you're only going to get the positive or negative, but you're only going to get 1/2 of that cycle out of the diode. So now we have it in diode mode, and one direction, I won't show any conductivity.
Overrange. Diode measurement 0.584 volts.
And
Overrange. Diode measurement 0.584 volts.
so we're getting the 1/2 of a volt across the diode to make it conduct, which is normal. If we reverse it, no circuit, which is what we should have. The positive lead of the diode is the anode. The negative lead where the meter goes is the cathode. So if you put the diode in the circuit, if you put the anode to the input and the cathode to the output, the current would flow from anode to cathode, and you would read a positive voltage to ground DC on that side of the diode. Another trick you can do in the diode mode is you can sort of check a transistor. Now it won't tell you the gain of the transistor, but you can tell if the transistor is shorted. So you have two types of transistors, NPN and PNP. On an NPN, the emitter is negative, and if you want to check that, you can go negative lead on the emitter, positive on the base, and you will show a conductive voltage, just like you do in a diode. Think of the transistor as two diodes back to back. What I have here is, I think it's a 2N2222, and this little beastie has a dot. So if you put the leads towards you, if you put the dot at 7 o'clock, the left-hand lead is the emitter at 9 o'clock. The top lead at 12 o'clock is the base. The right-hand lead is the collector. So I've tried the meter from emitter to collector, and I don't show a circuit because, remember, I said think of them as diodes back to back. However, if I go from base to emitter and base to collector with the positive lead on the base, I will show conduction. So now we have the positive lead on the base. This is an NPN, and we'll go negative to the collector.
0.685 volts.
So take 0.6 of a volt to make it conduct. And if we go to the emitter,
diode measurement 0.689 volts.
0.6 volts again to make it conduct. And if we reverse those leads, base to collector, base to emitter, they will not conduct. And if we measure across the emitter to the collector, they will not conduct. If they do, it means you've got a shorted transistor. A PNP transistor, you would check just the opposite, with the negative lead on the base. So that's kind of a sneaky way you can check a transistor with your meter if you don't have a transistor tester. The next thing I want to check is capacitance. I have electrolytic here. Their electrolytics, by the way, are polarized. There's a couple types you'll see. One has leads coming out of each end. Generally those, the positive lead is the end that has like the little indentation ring around it. This particular one has one lead longer than the other, and the long lead is generally the positive. And you do want to keep polarity correct. If you put it in the circuit wrong, they'll generally go up in smoke. And I'm measuring this electrolytic.
Capacitance measurement 35.73 microfarad. Capacitance measurement 35.71 microfarad.
Okay, so that's a 35 microfarad electrolytic capacitor. And remember, polarity does matter on those. Now I have a disc ceramic capacitor, And it's about the size of a nickel, so it's not going to be very big. Let's see what it says.
Capacitance measurement 0.021 nanofarad.
Come on.
Capacitance measurement 13.03 nanofarad. Capacitance measurement 13.01 nanofarad.
So 13 nanofarads, and the nanofarad is 1,000th of a microfarad. So that's a pretty small capacitor. As you step through the functions,
Diode measurement,
capacitance,
frequency, DC current measurement, AC current measurement.
and you get a single beep. This is continuity test. It doesn't speak, but it beeps. So if we touch the leads together, you can tell it's beeping. That means it's a short circuit. Over range means it's an open circuit. You would use this to test fuses, various resistance things. You could test coax jumpers, which I have one here. So right now I'm touching center to center, and I have a complete circuit. I touch shield to shield, and I have a complete circuit. I go center to shield, and I don't have a circuit, which means the cable's not shorted. Some antennas will show an open circuit. If it's just a dipole with shield to one wire, center to another wire, you're not going to show a circuit. If there's a balun at the feed point, then you will likely show continuity like this. And the only way to really test the cable is to go up and unhook the thing off. Anyway, the only way to really double check for sure the coax is okay is to unhook the cable from the balun and then check it. So I think that about does it for continuity testing.
Don't forget to subscribe to this podcast and visit www.blindhams.com.